All right. Hi, students. Welcome back to this channel. And today we will be doing a video on the last subtopic of chapter 4, which is solving equations involving indices and logarithms. Okay. And this is the most difficult part of the chapter, I would say, because it involves a lot of different types of questions and they can mix things around. They can mix indices and logarithms around and make you change bases, make you manipulate the working to get the answer, and they can do all sorts of things here. And then that is why this is one of the most challenging parts of the chapter. And people are normally afraid of the questions from this part of the chapter, right? Normally, exams questions would actually ask questions from this part, all right? Because questions involving solving the equations can involve changing base, can involve using the laws of logarithm. So it's like the final battle you're going to fight. Okay, after learning the first part, second part, third part, this is like the final battle. So you're going to use all your knowledge there to learn how to dynamically use them. Okay, and before I start, I would like to remind again, there are timestamps below. You can actually move to wherever you want to as you wish. Okay, so don't forget to refer to the timestamp below. Okay, so without further ado, we start. We will be covering the notes theory part on how to solve equations and indices involving indices and logarithm for this chapter. Okay, so what I'll do is to inform you first. Okay, chapter 4.4. Chapter 4.4. All right. So solving equations involving indices and logarithms, right? You basically need to know a few techniques to solve only. And that's enough for you to solve most of the questions. It's how you apply them. Okay. So there are a few techniques you need to know. And the first one is actually this. Okay. We look at index techniques first. Basically, you're solving equations involving indices. Okay, so what you want to do, right, is they give you a very complex question. Okay, let's just say they give you a very, very complex question. What you want to do, right, is try your best to manipulate and manipulate as well as to try to play with the equation so that you can actually end up with an answer of a to the power of n is equals to b to the power of n. Not an answer, a step of this. You can end up with this step. Okay, because why? When we end up with this step, we can apply this technique. Okay, what technique is it? We can apply the technique of a to the power of n. When you have a to the power of n is equals to b to the power of n, it automatically, you can say that a is equals to b. Okay, you can learn it generally. There are conditions where you can't use, but for exam questions, right, it's always possible for you to use this technique. Okay, so for example, let's just have an example. You might work out to the end, blah 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 blah. You might work out to the end, then you have a question like this. You have 2x plus 3 to the power of 3 is equals to 4x over 2. 4x over 3 power of 3. Okay, so you realize that it appears in a form where both of these two powers are the same. So you have power of 3 and power of 3. They are the same power. So what you do is you can automatically equate. You can say by comparison, because you're comparing. Okay, since this one is something to the power of 3, this one is something to the power of 3. I compare them. I can deduce that this one is equals to this one. 2x plus 3 is equals to 4x divided by 3. Okay. Therefore, what you can do is you try to solve for x. So you get 6x plus 9 is equals to 4x. 2x is equals to -9. X equals to -9 over 2. Okay, I bring over for division since it's multiplication here. All right, I divide both sides by 2 lah, basically. That is all you need to know about this trick lah. Basically, you try to manipulate until you get this step. But the steps of manipulating is the problem, is the main problem. You must understand, in solving indices and logarithms, right? The main problem normally comes from the manipulating. How do you manipulate a very complex equation to something like this that you can recognize and can solve? Okay, that is the main problem for logarithm. All right, so any notes you want to take down, after I finish teaching, you pause, you write the notes down. Okay, do not write down when I teach. Okay, unless it's something very important you need to write out immediately, then just pause, write down. But don't try to write notes when someone is teaching. Okay, a human cannot we cannot focus on too many things at once. Okay, we cannot multitask lah, basically. So for number 2, the technique number 2 is that such that just now we have same power, same index. It can also be applied when you have same base. When you have same base, a to the power of x is equal to a to the power of y. For example, they give you a question, okay? They give you a very complex question. I don't know what is it. It's a very complex question. Then you manipulate, such that you get this thing. Therefore, you can deduce. You by comparing, because this is a to the power of x, a to the power of y, and both of them are equal to each other. I think I've done a few questions on this in chapter 4.1. Okay, so when you have this thing, a to the power of x equals to a to the power of y, what you do is that you can straight away deduce that x is equals to y. Whatever is in the power is equals to whatever is in the power, because they have the same base and they are equal. Okay, so number 1, number 2 is very easy to remember lah. Basically, one is same power, one is same base. All right. Example wise, you can have a question. Complex. You manipulate until you reach a step whereby you say that you have something like this. You have something like don't use a lah. We use 3 to the power of 2x minus 3 is equals to 3 to the power of, maybe let's just say 2, 3 to the power of 2. You try to manipulate until you get something like this. So what you get is, you write by comparison. All right. So you have this one is equals to this one. 2x minus 3 is equals to 2. So 2x is equals to, bring negative 3 over for plus, you get 2 plus 3, which is 5. Okay. Actually, right. It's also very important to know. Most of our teachers will teach us negative 3 shift over there becomes positive 3. But that's actually not the right way to learn, okay? But for the purpose of generalizing everything, right, I would say this lah. But actually, that's not the way to learn it. Actually, you must know why for everything. The reason why, right, I shift negative 3 over for positive 3 is actually like this. I have a side note here a bit. Okay? So actually, right, just imagine you have something 2. 2 is actually equals to 2, right? Now, very obvious, right? 2 is actually 2, so 2 is equals to 2. So whatever I do to the left-hand side, right, if I apply the same step to the right-hand side, if I do something to the left-hand side, if I apply the same step, I do something. If I apply same step, you realize that the answer later would still be equals to the answer here. It's very logical, okay? Because you're doing the same thing here and you're doing the same thing here. So you will get the same answer because they originate from the same answer. That is the theorem you should apply upon. Okay? When two things are equal to each other, whatever you do on the left-hand side, if you do the same to the right-hand side, they would end up the same. The reason why I start with 2 equals to 2 is because when I give you complex problem, x squared minus 2x or minus 3 is equals to 0. People tend to fail to understand this is an equation, means the left-hand side is equals to right-hand side. They will think of this as a memory that their teachers have input to them, that this is a pattern that I must recognize without understanding. They actually do not really understand what is the meaning of equal. It's very easy to understand. A 5-year-old can understand what is equal, but they tend to neglect it, okay, and not emphasize it in their brain. So if you know what is the importance of equal, right, you will understand that whatever you do to the left and whatever you do to the right would ensure that the left and right will stay the same, okay? For example, if I have 2 plus 2 is equals to 2 on the up here, right? If I add 1 here and I add 1 here, it will become 3 is equals to 3. You see, both of them will still be equal. You get what I mean? The purpose I'm trying to tell you is the importance of this equality sign. And one more thing I want to inform you is that if you do the same thing to left-hand side and right-hand side, the equality will still work, will still hold. Okay? But that's not all the case. Some of the extreme cases, some of the cases you cannot actually do about it. For example, if I have 2 is equals to 2, can I divide by 0 both sides? Well, you cannot divide by 0, okay, because it will leave you an undefined answer. All right? Okay, this is understandable. That is why, right, if you are a maths freak, right, you would realize that there is one quite a popular proof of 1 is equals to 2, which is wrong. Okay, you can go and check that out. Proof of 1 equals to 2, and find out the mistake of that working, and can tag me if you want to. Okay, there's one guy who proved this thing, but there's a reason why, and he proved this thing basically. He proved this thing. Oh, he did some things. Then he proved 1 is equals to 2. But you know that 1 cannot be 2 because 1 is actually equals to 1. 2 is equals to 2. So how he managed to prove 1 is equals to 2 is that one of his mistakes, or one of his steps is a mistake. Okay, so you must realize that mistake. All right. I don't remember whether I know to prove it or not, so I wouldn't want to try it now. I don't think I remember. Okay. So this is the importance of it. So coming back to this part, right? If I want to bring -3 over for plus, right? What is the idea behind? It's actually this: 2x minus 3 equals to 2. So both of these two things are equal, okay? So in other words, right, you don't look at the equal sign, you just cover this thing up. You know that this one is actually 2. It's equals to 2, okay? I want you to think of this way. If you are thinking of this way, then it's good. If you are not, then I want you to think of this way. This is actually equals to 2. It's not just by reading this statement, 2x minus 3 is equals to 2. Not just by memorizing the statement and read it out. But more importantly is to understand that, okay, in my mind, I know that this is actually 2. That's what you need to really emphasize in your brain, okay? The understanding behind it. So what you do, right? What you do to the left-hand side, if you do to the right-hand side, you will get the same equality sign. Okay, so what is the purpose of, what are we trying to do in this question? We are trying to solve for x, right? When we want to try to solve for x, right, the general rule is that we want to leave x on the left and throw everything to the right. Correct. So if you want to leave x on the left and throw everything to the right, we must slowly isolate x one by one. Okay, so which one should I isolate first? So what you do, right? Okay, first thing I can tell you, most of the teachers will tell you shift the -3 over first. Okay, so I'll use I will deal with -3 first. So what I'll do is, how do I remove this -3? Okay, I've got to do something on the left-hand side to remove the -3. So -3 plus what will give you 0? Because 0 means you have eliminated it. So -3, you got to plus 3 on the left. So when I do plus 3 on the left, I plus 3 on the right. You understand what I mean? So you are left with 2x plus 0 equals to 2 plus 3. Okay, so you have 2x is equals to 5. Now you divide left-hand side with 2 and divide right-hand side with 2. Why do I divide with 2? Okay, I divide 2. You see, now I do not say I shift 2 over for division. I don't say that. What I say is I divide 2 on the left, I divide 2 on the right. So what you get is x is equals to 5 over 2. That's how you do it. You understand? That's the actual meaning of doing it. You see, whatever I do on the left, I do on the right. Whatever I do on the left, I do on the right. Okay? So this is a very important concept. Let me teach you one more thing. What if your teacher says, right, oh, why can't I shift 2 first? Okay? Why can't I shift 2 first? You will understand using my method. Actually, you can. Okay? But it's a bit more complex. You see, what I do is, if I want to isolate 2 first, what I do is I divide by 2 on the left-hand side, I divide by 2 on the right-hand side. Correct enough? Notice, when I divide by 2 on the left-hand side, I divide the whole equation by 2. So what I'll leave myself is 2x minus 3 over 2 is equals to 2 divided by 2, which is equals to 1. Okay, that's what I'm doing. Then what I do now is I try to simplify the top. Okay, this is a very important thing that I want you to note down. When you have more than one terms on the top, okay, more than one terms on the top, you write notes if you want to. Listen carefully. Number one, if you have more terms on the top and you can split the fraction. How you split the fraction is like this. You can become this one minus this one. You can split it. You can split it into 2x over 2 minus 3 over 2 equals to 1. You can do it. But if you have something like, let's just say, if you have something like, let's just say, if you have something like this, okay, 2 over 2x minus 3. Can you separate it? Can you separate it? You cannot, all right? You cannot. Okay. So I want you to know, if you have more than one terms on top, you can separate. Okay? But that doesn't mean if you have more than one terms below, you can separate. It doesn't work, okay? You can only separate when you have more than one terms on top. Okay, on top, don't forget it. All right, so we come back to this. So you can separate, I know, because the terms is more on top. And how do I define terms? Terms are basically the things that are separated by plus or minus, okay? So if 2x minus 3 plus 4y, 3 terms, don't forget it, okay? I define it, this how I normally say it lah. All right, so I divide by 2 already. So our purpose is to isolate x, correct enough? So I divide by 2, so I can cancel the 2. So I'm left with x minus 3 over 2 is equals to 1. So if I want to isolate x further, what I do to the left-hand side is I plus 3 over 2. And to the right, I do the same, plus 3 over 2. Do you understand? So what I do to the left is that I want to cancel out the 3 over 2 here. So I'm left with only x. Okay, so to the right, since I've added a new 3 over 2, I'm left with 1 plus 3 over 2. So which gives me 5 over 2, which is the original answer that we got just now. All right, so you can work these two things out. Use my method and you'll never go wrong. This is not my method, this is the correct method. I don't want to call it my method. It's just that too few people are teaching this way. Okay, so from now, I will try to use this method, this way to teach because I want my students, which is you guys, to learn the correct way. All right, so since we have this thing, okay, coming back to the question, I can compare 2x minus 3 is equals to 2. Is equals to 2, correct? So what I do to the left is I plus 3, and I do to the right, I plus 3. So 2x, when negative 3 plus 3 on the left, you get 0. On the right, you plus 3 basically. So on the right, you get 5. Then what you do is you divide by 2 and you divide by 2. You get x equals to 5 over 2. This is the way I want you to learn. It's not necessary for you to write these steps, but to learn this way, to understand things this way, okay? Very important. All right, so that is for example for the second technique. We move on to the third technique. Third technique says that if you happen to have a to the power of m over n, I repeat again, a to the power of m over n, you can actually express it in this way, okay? This is like the power root. I ask you to remember the acronym, right? A power root. So it's something like a to the power of this, the power, and this is the root, okay? This is the power, this is the power, this is the root. So what you do is you put m here, this is the power, and your root you put here, okay? It doesn't matter which one you solve first. You can solve the root first, then you power it, or you power first, then you root it. Understand? It doesn't matter. It will turn out to be the same answer. If you are still not good in this, can refer back to my first video, theory video on my 4.1, indices and law of indices. All right. So that is for this thing. We will move on to. So what if you have a to the power of m over n is equals to b? Okay. I will change the alphabet a to x because normally questions will ask us to solve for x. So x is like, it's more familiar for you guys that you know that you want to solve for x. Okay, so if you want to solve for x, what you do is actually, if you were to think the method that I've taught you, right, you try to do something to the left and do something to the right so that you can eliminate this m over n. So what you actually do, right, when you have power like this and you want to eliminate it, is you try to think, what do I have to power left and power to the right so that I can eliminate this thing? You get what I mean? For example, if you have 2x plus 3 just now is equals to 4. I want to eliminate this 3. What I do is I minus 3 on the left, I minus 3 on the right. Similarly, I can use the same approach for this power thing. Okay, what do I do is I power to the something, I power something. What do I power with? It has to go back with your law of logarithm already. What do I power with? I give you 5 seconds to think of it while I write this thing down. What do I power it with? Okay, so you want to make it as x only, right? You want to make it as x. And I told you x or any other alphabets or any other unknowns has a power 1 above them. So basically, in simple words, you try to make this m over n to be 1. How do you make it 1? You power of something. Power of what? You power n over m. Okay, just take my words first. I power of n over m. Why do I power n over m? Because by law of indices, number 3, in lecture, in video 4.1, we realized that when you have two powers side by side, you multiply the powers. So you can cancel the m up and down, cancel the n up and down. So you're left with x to the power of 1, which is x. So whatever you do to the left just now, I did this to the left, right? I got to do it to the right also. I've got to power of n over m also. You understand? So I straight away get x is equals to b to the power of n over m. That's how I arrive with this thing. Basically, if you learn maths the right way, right, you don't have to memorize so many other things to cover the loopholes for not learning the right way. You get what I mean? If you learn the right way one time, you can apply to anywhere. You see, in fact, I can apply here. You get what I mean? So as I said, learn the right way. As I taught you, do something to the left-hand side, you do the same to the right-hand side. And the understanding of equality. That is what I want you to learn, okay? So this is what I've proven to you. Similarly, if you have something like this, a to the power of negative m over n is equals to b. What you do if you want to find a, okay? Let's just say if I want to find, let's not use a, okay? Because a is a bit too theoremized. I don't know if that would exist. Let's just use y. Y to the power of negative m over n. So how do I make this power 1? I've got to power y equals to y to the power of negative m over n, power of something. So I've got to do the same to the right-hand side. Okay, what do I power it with? I want to make it 1, right? So I've got to multiply with something. Of course, I need to times a negative. Why? Because I want to make it to be y to the power of 1. This one has a positive sign. So I have to times a negative to make this sign positive. Okay? So because negative, positive, you're going to multiply these two things together. And the value I'm going to times here is the opposite of this fraction, which is n over m. Okay? Because only when I times the opposite of the fraction, I can cancel them out. And this negative will become 1. So what I do is I get y is equals to b to the power of, when I times, not times, when I power the left-hand side with negative n over m, I do the same to the right-hand side. Negative n over m will stay inside here. You understand? So I get b negative n over m. That's how we arrive with this fourth technique. It's not hard to understand this part, all right? So that is all we need to know for index techniques, okay? As I said, these are the techniques you may learn 100 times, but not be able to apply to the questions. What is important is to know them, recognize them, learn the correct way. So I'll write a very keyword, learn the correct way. If you were to follow my video until now, right, and not skip, right, you would realize there's a method I used to impose to my students, which is the correct way to study. And I hope that all of you can follow. Right? Learn the correct method. Understand it. All right. So similarly, we have indices techniques, we have index techniques, we also have logarithmic techniques. The idea is all the same, you know. Okay. Okay, wait. So if you have, let's just go through the logarithmic techniques. If you have a to the power of x is equals to b, I want to find x. How do I find x? Okay, it's actually the same idea that I taught you. How do you get this thing? Okay, you might ask me, how do you get this thing? It's the same idea. If you do something to the left, you do the same to the right, you will get what you want to get. You will eliminate what you want to eliminate. Okay, but mark my words, this, even though it's true that when you do, if you do the same thing to the left and the right, you can eliminate certain things and find your answer. But there are some conditions. I mean, there are some workings. There's some things you cannot do. You cannot do it with lah. Okay, but those are the extreme cases whereby you seldom meet them one. I mean, when you divide by 0, you cannot divide by 0 because it will give you infinity or undefined. All right. Other than that, this is a correct way to learn. All right. So you might think, how do I want to remove? How do I want to isolate x? How can I isolate x? I want to make x as a subject. Now x is on top. Okay, when you want to make a power to be a subject, you have to use log every time. You remember that. If you want to make an index to be a subject, you have to use log. And what do I log with? What base do I use? You might think, okay, I can use log base 10, log base A, log base B, or log base X. These are the 4 things you can think of that are common because A and X and B are here. And 10 is very common log. And you might think of the correct answer. The correct answer is actually to use log base A. Why? Because I know that when I use log base A, X, after I shift this X down, I leave myself with log AA, which is equals to 1. You get what I mean? So whenever you want to log both sides, right, you look at the power, this one, the one with power, and you log its base. Log base A, X is equals to, and when I do log base A on the left-hand side, I will do log base A on the right-hand side of B. You understand? So now you bring your X down. Okay? So when I bring my X down, what will I get is, you will get log base AB divided by 1. Correct or not? So you get X is equals to log base AB. And then I want you to realize something. Isn't this the first lesson where we learn what is log in 4.3? This is what we learned in log, right? 4.3. We remember we learned how to change from index form to logarithm form. Log AB is equals to A. Remember we memorized is equals to X. Remember we memorized this? I did not explain to you this thing, right? But you see, if you use the correct method to study, right, you would realize that you can derive things naturally. You see, I derived this thing suddenly. In fact, this is actually the conversion between index form and logarithmic form. You see, that's the power of understanding. Once you understand something, you can create things. You see, I've just created one. You get what I mean? Okay, so I want you to really learn this way. It's not hard, okay? It's even easier because you can generalize everything. You can generalize everything with just one correct understanding instead of memorizing so many things for different scenarios. That would be very crazy. Okay, so that is how you solve for X to use log. Okay, or what you can do is you can use, if you want to find X, you can use your calculator with log base 10. You can solve it using a calculator. And I would like to give you a small note here. Actually, log base 10, some books might write it in the form of log LG. This is automatically meaning log base 10. Don't forget, LG is log with the base 10. Okay? So if I want to use log base 10, if the question allows me to use log base 10 to solve, in other words, they allow us to use scientific calculator to solve, what do I do? Okay, so what you do is, as usual, you log both sides first, log base 10 both sides, a to the power of x is equals to log base 10 to b. Log both sides, then you shift x downwards. X log base 10 a is equals to log base 10 b. So how do you find x? This is something like a multiplication, as I told you many times. When you shift the x down, this is like multiplication. You divide left-hand side with log base 10a. Okay, you see, now I don't want to say shift it over for division. I don't want to say that. What I want to say is you divide left-hand side with log base 10a, you divide right-hand side with log base 10a. It's the same thing I'm dividing. So I can cancel this log base 10a, I'll get x only, because there's an x multiplying log base 10a here. So I'm left with x since I've cancelled them to become 1. So what I get on the right-hand side is equals to log base 10b over log base 10a. Or I can write it in simple form, log b, lgb over lga. And this is what you have here. Okay, if you know your understanding right, if you understand things well, you can actually work things out very fast. You can actually work very fast. I show you a speed of mine if I don't memorize and if I work it out, I would know that ax equals to b. Or I know that log a then x shift in front is equals to, and I do log b. So what I do is x is equals to log b over log a. How long did I take? How long did I take? I just took like 10 seconds, right? And I actually managed to explain some more. So it's actually very fast if you can derive it. Okay, I hope you understand what I mean. When you write the word log LG, in terms of LG, you don't have to put the 10, okay? LG is actually same as log, write the word log base 10, this same. You don't have to write 10 here. It's automatically understood, it's 10. Okay, so that's the first one. And second one is also the same thing. You would want to solve a very complex logarithmic equation until you arrive where? Until you arrive at a stage where you have log a, let's just say log a 2x minus 3 is equals to log a 4x plus 8. Since you know that log a and log a, they are same thing, you can compare the right hand side. You understand? Okay, I want to point out some common mistakes people make. Whenever you want to compare this thing, take a note down for yourself. This is very, very important. Very, very important thing I want you to note down. Okay, this is a very important thing I want you to note down. When you have log base 10a on the left and log base 10a on the right, and you want to compare, if you want to compare, make sure that you only have one log on the left and one log on the right. One left log, one right log. Okay, if you have log base a x, what if, okay, let's just not right here, let's not waste time. If you have log base ax plus this, you have two logs on the left hand side. Don't do it. Okay, don't do it. What you do is you combine these two logs first. What you do is you combine this thing first. Only you compare later on. You understand what I mean? You don't straight away compare now. You might be so excited. You say, oh, log base a, log base a, log base a. I'm so happy. I will compare. Then you end up getting half the marks or not even getting any marks. You get what I mean? So I want you to make sure that there's only one log on the left, one log on the right, and both of them must have the same base. Then only you compare. So what I do first is I will combine log base a. I will combine where you have log with the same base plus u times the content of the log. What you get is x times 2x minus 3. Okay, that is if you have two logs and separated by a plus, two logs separated by a plus and same base. What you do is you can multiply the content inside. This is based on your law of logarithm number 1. Okay, please go back and refer the reverse process of law of logarithm 1. Please go back and refer if you don't know. And if you haven't watched this video about it, you can go watch it first before you actually come to this part. Because I assume when you arrive to this subtopic, right, you have already familiarized yourself with the basic techniques, with all the understandings you require before you actually attack the final battle. Okay, so once you have combined, it's equals to log base a 4x plus 8. Okay, you notice there's only one log on the right, one log on the left, and both of them have the same base. You can compare right now. Do you understand me? So you compare. Okay, by comparison. My wording, sorry, you understand what I write? That's it, okay? X times 2x minus 3 is equals to 4x plus 8. Then you expand. 2x minus 3x is equals 2x squared minus 3x equals to 4x plus 8. Then you arrange in general format, because I know quadratic equation, I must arrange in general form first before I can either factorize it, either solve using completing the square, or either solve using the quadratic formula. If there is no beautiful roots, if it is not factorizable. Okay, that is in quadratic chapter. Okay, 2x squared, then you bring minus 4, you bring 4x on the right to the left, or in other words, if I use the correct method, I would minus both sides with 4x. So I get minus 3x minus 4x gives me minus 7x. So on the right hand side, when I minus 4x from 4x, it gives me 0 plus 8. Okay, plus 8. Then I bring the 8, then I minus 8 both sides. I would just say I minus 8 both sides. Okay, so I get minus 8 equals to 0. Okay, then you solve. I won't want to solve. Okay, I don't want to solve this thing because I just simply created this value. I'm not very sure whether it's solvable or not. B squared minus 4ac 49 48. Yeah, it's not solvable. It won't give you. Oh, it's solvable. It's solvable. Yep, it's solvable. This one you can solve yourself lah. I won't go through now because I just created this question out of nowhere. All right, so that's the idea. Okay, and since you must make sure there's only one log left, one log right. Okay, similarly, maybe I missed out the point just now. I want to point out, even if you're dealing with, even when you're comparing like this thing, you're comparing like this thing, you're comparing a to the power of n is equals to b to the power of n. Okay, so let me think. Okay, what if you have something like this? if you have, for example, 2 to the power of 3x, no, 2x to the power of 3 is equals to 4x minus 1 to the power of 3 times wait, I want to write it down a bit because okay, times what? Times, for example, let's just say, for example, 3 to the power of 3. You see, there's only one n here, okay? There's only one n here. Do you see one n and one n on the left and one n on the right? So you make sure whatever you're comparing, right? Whatever is the same, whatever is the same on the left and the right, you make sure there's only one of them. For example, if it is 3 here, you definitely want to combine. Okay, wait, this is supposed to be in a bracket. I'm so sorry. This is supposed to be in a bracket. Okay, because this n belongs to A. Basically, the n belongs to everything that is attached to. So I must attach 3 to something also. Because if I don't put a bracket, it will mean that this 3 belongs to x only. Okay, then you cannot compare. You got to cube root this 2. Cannot. But I don't want to complicate it first. We will solve that in questions. So I put a bracket here. Okay, so what you have now is you would want to combine these 3 first. Remember, I told you when two things have the same power and they are multiplying each other, you can combine them. Remember, I told you an times bn. You can actually combine them as a times b to the power of n. You can actually factorize the power. You can only factorize the power when it's times, okay? Don't forget. I don't call it factorize. I call it, you remove the power basically, okay? You take out the power. Okay, so since these two have the same, they live in the same world, I call it they live in the same world. So how do you define whether they're living in the same world or not? You see whether they have the same power or not. Okay, they have the same power, so I can multiply them. So 3, when I multiply with this bracket, what do I get? 3 times 4x gives you 12x. 3 times -1 gives you -3. Power of 3, don't forget. I'm just removing the 3 out only. Okay, so until now you have 1 power of 3, 1 power of 3, then you can compare the remaining things. You understand? You don't compare here. You compare here. This is a very, 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 very common mistake that students tend to make. Okay, even me myself. Similarly, for the second rule, for the second technique, when you have base ax equals to base ay, you must make sure that it is only a and a on the left and on the right. It's only one thing on the left and one thing on the right. For example, if you have 3 to the power of 2x minus 1 is equals to 3 to the power of 4 times 3 to the power of x. Okay, let's just say this. What you want to do is, because you're seeing 1, 3 here, you want to make sure you only seeing 1, 3 on the right hand side. You understand? So what you do with the right hand side is you try to combine them into 1, 3 only. So how do you combine them into 1, 3? By law of indices. Law of indices, you have the same base. If you have the same base, multiplying each other, but different powers, you add the powers. Don't forget, don't get confused between all these things. Now it's same base, different power, which is law of indices. What you do is you make them into the same base and then you add the power. Okay, until there's only 1, 3 on the left, 1, 3 on the right, they are completely identical. Then you compare the top. Then you solve for x. All right, this is the method I want you to remember. And then we will be solving questions later. This one has a lot of questions. Okay, I will go through a lot of questions with you. There are 4 parts. I will probably make 4 videos for these 4 parts of questions. All right. So these 4 parts of questions I'll discuss in the questions videos. All right. So any theory, fundamental understanding that you still do not get right, that you feel you're still blurred with, you can always leave a comment down in the comment section below so that I can read them and I can actually come back to you. All right. So with that said, I end this video right here. I don't want to make it too long anyways. Okay, so I'll end this video here. I'll see you in the next one when we are solving questions. Bye.